All right, number 1, it was a solving problem. Okay, we're solving for x. When we solve, we check, do we need to distribute? Do I need to distribute on this problem? No parentheses. Then we need to check for like terms. Do I have like terms on this problem? Yes, I do. What are my like terms on the left? 15x and negative 5x. What is 15x and negative 5x combined to be? 10x. Good. If you can do that, then what we're doing today is not going to be very hard, okay? Because it's a lot of combining like terms. Equals plus 4 just drops down. What about this side? Do I have any like terms? Yeah. What do I have? Okay, what is this implied to be, that plus x? That's a 1x. So I'm going to drop down the negative 3 first because it was first. But this is a 1x plus a 2x, which is a, what kind of 3x? Positive. So I have to put a plus sign separating those terms, okay? So after I do that, now my goal is to get x on one side and my numbers, constants, on the other side. Does it matter which side I move the x to? No, it's up to you. What do y'all prefer? Do y'all want to move the 3x or the 10x? 3x. How do we move a 3x? Minus 3x. Can y'all see that okay? It's kind of bright. Minus 3x right there. Okay? And then what does this give us? 10x minus 3x is 7x plus 4 equals negative 3. That's going to go away. So I get those on the left. So what do I need to put on the right? The constant. So how do I move the constant of positive 4? Minus 4, minus 4. That gives me 7x equals what? Negative 7. And then what do I do with the 7? Divide by, and so what does x equal? X equals negative 1. Okay, so we actually found a solution there. So we will be doing combining like terms today. That's the main idea of today. There is some vocab we have to go over, but it's not too bad. Okay, all right, 2 and 3. These are simplified. These are exponent rules. So those of you that were gone last class, we didn't learn anything new. But we just practiced our exponent rules. It was a really good day of practice. So if you were gone, you did miss a lot of practice, okay? Plus the check for understanding. Our check for understandings, there was some pretty good. There was some in the middle. There was some that were not so good. So we really all collectively need to improve on our exponent rules because there's going to be an entire test topic on exponent rules. So we're going to keep going, but we got to fix these exponent rules by the time we get to next Friday, okay? So what exponent rule am I using on number 2? Remember, we've got kind of 3 big rules here. Where's my formula chart? Blue one. Is it still up there? Maybe. Okay, we've got the product rule when we have things being multiplied. We have the quotient rule when we have things being divided. And we have the power rule when we have outside powers, okay? Outside powers always have to go first. Are there any outside powers in this problem? No, so don't have to worry about that. And if I look at this problem, I can already see there's a fraction bar, so that is drawing my attention to this, okay? But the other thing that I see in this problem that I don't like is what? Negative what? Exponents. Negative exponents are the problem. There's nothing wrong with negative coefficients. If this was a negative 20, we don't care. We can deal with regular numbers being negative. The problem is negative exponents. And I always, typically, will choose to fix negative exponents before I follow rules. That's typically how I do it, especially if it's a fraction. That would always be like, number 1, I'm going to fix that, okay? So our negative exponent rule is on our formula chart right here, and it reminds you that you got to take that base, you move it to the other side, it becomes positive. So the first thing that I'm going to do, and again, with these, I'm going to give myself some space, because I know it's going to take me a few steps to get there. Let's write what's okay. Is there anything wrong with 20 being on the top? Nope. So I'm going to leave 20 right there. What about 15 being on the bottom? Anything wrong with that? No. Okay. Now, I do need to simplify that, but that will be the next step. Okay. What about into the negative 5? Is that okay on the top? No, I circled that. So where does where does base n need to go? The bottom, and then that exponent becomes positive 5. P to the 3. Is there anything wrong with p to the 3 on the top? No, because it's positive. R to the negative 2. Where does that r need to go? To the bottom. Exponent becomes positive. All right, I already brought the 15. What about n to the 3 on the bottom? Is there anything wrong with that? Write it down. P to the 6 on the bottom. Anything wrong with that? No. R to the negative 4 on the bottom. Is there something wrong with that? Where does it go? Top. Exponent becomes positive 4. Okay? Now, how do I know I'm not done? When am I done? Everything shows up one time. I've got 2 n's, I've got 2 r's, I've got 2 p's. I'm not done. Okay? So now we're going to go and we're going to use this rule, which is our quotient of powers. Technically, our exponents are subtracting. You can also think tug of war. And I'm going to simplify one thing at a time. Now, the first thing I'm going to look at are these front numbers. Are these exponents? Am I following tug of war rules when it's regular numbers? No, regular numbers follow regular rules. So put 20 over 15 in alpha y equals 20 over 15. And alpha y equals, and what does that reduce to? 4 over 3. You are done with that part. Check. Check off the coefficient. Finished. Okay? Daniel, what letter do you want to do next? P. Okay? Daniel chose to do P first. Is it okay if you did N first? Sure. Doesn't matter. It's up to you. Let's look at the P's. We got P to the 3rd and P to the 6th. Now, these are 1 over each other. Okay? When they're over each other, you're using this rule. Tug of war. Subtraction. Who wins between the P's? Top or bottom? Bottom by 3. So I put P to the 3 on the bottom. Check, check. Okay? Nick, what letter do you want to do next? N. Okay, let's look at the N's. We have 2 N's. But they're both on the bottom. Okay? They're side by side. So what rule is our side by side? Product rule, which means you add the exponents. And it's going to stay in the bottom. So N is going to stay in the bottom. 5 plus 3 is 8. Check, check. And then now all that's left is R's. R's are 1 over the other. So again, I'm doing quotient rule, tug of war, whatever. Where does R go? Who wins? Top by 2. Okay? Was that bad when you break it down like that? No. It's not that bad. If you just piece by piece, letter by letter, work the problem, now you're done. There's nothing else to do. You've got 1 left of everything. Okay? We did a couple of examples like this last class on that mixed practice. If you were gone, I would suggest you look at that. All right? Test like, right here, star. Same thing with number 3. All right, this one. What rule is this? Right, but what rule is it? Is it a side-by-side multiply? Or outside power? Outside power rule, which means you take the outside exponent and you multiply it in. What you got to be careful about, though, is if you're doing outside power rule, make sure everything has an exponent. C has an exponent, B has an exponent, A has an exponent. Miles, what did I tell you to give 81?
Its own exponent.
Which is a 1. And the reason I think this will help you get these right. These problems turn very easy if you remember to do that. Because you have to know what you're multiplying the exponent by. All right, Miles, tell me what to do. What'd you get next? So you multiply your outside power in. And so what'd you get? 81 to the...
81 to the 4th.
To the 1/4. Okay. Then you got A to the... A to the 3rd. How'd you get 3? Multiply 12 by 1/4. That's all we're doing. All right, B is to the... And then C is to the...
Second, I don't know.
Yeah, you're right. Okay. So A, B, and C are actually done, but do we want to leave this right here? Do we want to leave 81 to the 1/4? No. That's not fully simplified. Whenever we have a number raised to an exponent, we want to put that in our calculator. We want to evaluate that, find the value. So make sure you know how to type this, hint, hint, okay? So I'm doing 81, and I'm raising it to, it may be a fractional power, it may be a whole number power. Either way, I'm still doing the same calculator steps. 81 to the 1/4 power is what number? 3. So fully simplified, I would need to write that as 3, and then A to the 3rd, B to the 5th, C to the 2nd. Now I'm done. That's my answer there. Okay? So again, you guys that were absent last class, and there was quite a few of you. So let me just show you what all's up here, okay? We went through, I had a video that I made, I sent to you. We went through this slideshow. It has just a bunch of exponent practice and problems and answers, okay? So like there's a problem and then there's an answer with work. So I would practice those with me in tutorials at your own time. I don't know, whenever you need to. We got to make sure we get this. And then there's where the CFU is. So if we have time today, my plan is to, those of you that didn't do so well in the CFU, we're going to try to do some little interventions there. Some of y'all are just crushing it. But again, I have some extra exponent stuff that I put on Canvas for you, just depending on where you stand, okay? Because we're kind of all over the place, and it's kind of stressing me out. But we do need to continue learning. Again, I told y'all today is really not, it's a nice break because exponent rules are a lot, okay? Today's math is really not that crazy. Go ahead and flip over to page 12. We are going to introduce some vocab though, okay? Flip. And this vocabulary, you're going to be hearing me say these words for the rest of the year, okay? And then you're going to hear them again in geometry and again in algebra 2 because I use these words every day in algebra 2. And so I kind of want you to know what's going on here. I'm not going to like give you a vocabulary test, but I just don't want you to like stare at me if I say polynomial, except for right now. You can stare at me right now when we say polynomial. But after today, we should be good, okay? So polynomials are an addition or subtraction of separate terms, okay? So we've been dealing with polynomials for a while. We just haven't been calling them polynomials. So if you even look at your left-hand side right here, this is a polynomial. You've got a couple terms being added, some being subtracted, but each separate thing is called a term. I know I've used that for vocab before. So there's some special names for some types of polynomials that we'll go through here. And the first one is a monomial. And I'm going to kind of box their prefixes because I feel like y'all have seen these before. Mono means that there's one. So monomials are one term, okay? Now, they can be just a plain number. They can be a plain variable, or they can kind of be a combo right here. But there's no pluses or minus signs with monomials. So here's an example, negative 2x to the 5th. I'm going to write in a couple other. 3 is a monomial because it's just one thing, okay? X is a monomial because it's just one thing, okay? So those are just one and done, monomials. The next one is a binomial. Prefix is bi. Binomial means there are how many terms? 2. So you can have two things being added or subtracted. X squared plus 5 is a binomial, 2 terms. You could do 10 minus x. That's a binomial, 2 terms, okay? And again, it's pluses and minuses that separate everything. And then we have trinomials, which we'll talk about a whole lot this year. And those have, what do you think? 3 terms, okay? So you have term, plus or minus term, plus or minus term. Those are trinomials. After that, you can have polynomials mean many. So technically, these are kind of all under that umbrella of polynomials. But these are monomials, binomials, trinomials. Those are the only ones that have special names. After that, you just say, oh, there's 4 terms, or there's 5 terms, or there's whatever. So, what we're going to do today is we're just going to be adding and subtracting these. And I promise you this is really nothing crazy. You have been doing these skills before. Anytime I say combine like terms, and I know I've said it multiple times this year, that is what we're doing today, okay? What's going to get maybe a little bit trickier is we're going to be throwing more at you than just 15x minus 5x. We'll put some other terms on there. We'll have some x to the second power terms or maybe some other exponents on them. But to be a like term, they have to be like matching exactly, okay? They have to have the same variable, the same exponent, and then all you do is deal with the coefficients, the numbers in front. So here's some examples for you. They're already kind of worked out. We are going to review the distributive property, but y'all are really good at that there, okay? So this is what we're doing. We're doing this page, and that's it. Are you with me? Flip over. We're going to practice our vocabulary. We're going to practice our combining skills. And we're going to knock these out. Brayden, flip. Okay? So, the instructions for these are going to say to simplify. So, anytime I say simplify, you're condensing. You're making something smaller. We give you something expanded out. We're going to clean it up and make it look as simple as it can go. There's no solving. We're not going to get any x equals today other than that warm-up question. This is all just going to be, take this expression that's in multiple terms and shrink it down. Okay, that's all we're doing there. Like terms have to be the same variable and the same exponent. So they have to match exactly. Okay, an x and an x squared are not like terms because x has an exponent of 1, x squared has an exponent of 2. So they have to be perfect matches. And terms, when you have a term, you got to pay attention. The positive or negative is like a name tag. It's telling you this term is positive if there's a plus in front of it, or this term is negative if there's a minus sign in front of it. So you got to pay attention to those signs in between, okay? So if you look at all your instructions here, it says simplify. So that means just do the operation. We kind of put some different examples. Are there any parentheses on this first one? Y'all see any parentheses there? Are there parentheses on this one? It just kind of depends on how the problem's written. Sometimes they're necessary, sometimes they're not. So let's start with the first one, okay?
Just real quick. Y'all see an equal sign?
Thank you.
There's no equal sign, so we're not going to be doing opposite operations. Right? Equal sign, when we move across the equal sign, that's when we do the opposite. This one, we're just doing what it says. Okay? Same stuff you've done since, I like to say, first grade.
Exactly. Combine like terms. Okay, that's all we're doing today. These are just expressions. There's no equal signs. We are strictly just combining. I like to do like shapes and underlines and stuff, make it kind of fun, because that's kind of, again, how my brain works, and it just helps me separate the problem out. So let's look at the first one. 3m minus 2n plus 9p plus 6n minus 8m. Whew, that's a lot. How many terms is that? 1, 2, 3, 4, 5. 5 terms. So there's not really a special name for that, but that's a polynomial. So the first thing that I would do is I'm going to, anything that has a m with it, I'm going to underline. So I got 3m right there. Does my next term have an m? No. Does my next term have an m? No. Next? Next? Okay, I'm going to underline, and look what I underlined with it. That minus sign. That's telling me that this guy is negative. Okay, so I'm going to underline that sign with it. Okay, and then I can put those together. How do I combine those? 3m minus 8m. All I do is deal with the coefficients. Okay, what is 3 minus 8? Or you can think of it as 3 plus negative 8. Okay, however works for you. Don't get confused on the minus signs there. Okay, you can always think of it as an addition. Or technically it's a subtraction. So what do we get either way? What kind of 5? Negative 5. Now what makes those terms alike? They both have a m. The number in front changed. The variable is not changing. I need you to understand that. Your variables, your exponents should not change on these. It is strictly just the coefficients, okay? And I sometimes like to mark these off when I'm done because I know I simplified, and that's as far as I can go with the m's, okay? All right, next variable I have is the n's. I'm going to circle numbers or terms that have an n with them. And notice I included their sign. Okay? Brayden, my n's, what am I putting together?
Negative 2n and 6n.
Negative 2n and positive 6n. What is negative 2 plus 6? 4. What kind of 4? So I have to put a plus 4, and what makes those alike? They both have a n. Check, check. And then the last thing I have is a positive 9p. Is there anything to combine that with? Can I just get rid of it? No, what do I have to do? I have to put the n, and I have to put a plus sign in front of it. And there's my answer. Okay? Now, with a problem like this, when I kind of got all different letters, like order technically doesn't really matter. I do want to be careful on problems like this where I have x squares and stuff. I'll talk about that in a minute. But for that, that's just an adding problem. I'm done. I'm finished. There's nothing else I can do. Okay? Was that crazy hard? No. Let's look at the one right next to it real quick. Okay, I'm going to let you guys try this one. What's different about this problem right here? The negative 5x plus 3y plus z. What's different? Parentheses. But what sign is in between the parentheses? Okay, does a plus sign change anything? No. So do you have to have those parentheses there? No. You could kind of look at it just like we did that other problem. But a plus sign in the middle, you're just combining like terms. Okay? So go through, do your underlines, your boxes, your squares, whatever, and let's simplify that down.
See if you can do it real quick.
5x plus 1y minus 4z.
That's what I got. Very good. Negative 5x plus 1y plus 4z. Do you have to put the 1 in front of the y?
No.
No. If you did, is that okay?
Yes.
Yes. Okay, Miles, I saw on your paper you had plus negative 4z. Is that okay if you put plus negative? That's okay. Is it going to look like that on a multiple choice, though? Probably not. Okay, so be careful with that. And so this is one way you could write it. Again, I would probably go in order X, Y, Z, but if you went in a different order, that's okay. You good? Does she need me? Okay. All right, let's do this next adding one right there. Up, okay? But again, it's because our exponent rules are only when we do multiplication, division, or outside powers. So this is just addition. So I kind of emphasize circling that sign here. So if I were to underline these, I got a 3x squared and a 1x squared. That gives us a 4x squared. Okay. Typically with these x squareds and these types of polynomials, we do want to put them in order with the highest exponent to the lowest. So I would want to put my x squareds first, and then I would want to put my x's, and then I would want to put my constants, my plain numbers, okay? And we'll get to that, but you're going to see a whole lot of stuff, like literally for the next semester, that kind of look like these trinomials here. Because this is a trinomial plus a trinomial, right? How many terms in the first one? 3 plus a 3, okay? So that's 4x squared. Now keep going. Okay? Heidi, what'd you get for your x terms? What combines there? Negative 9x, very good. And again, no changing the exponents. It's really just, honestly, the way I kind of think about the exponents for this is identification of what's alike. Other than that, I'm just looking at the big numbers. Jahan, what about your constants? What do they combine to be? What? Well, what's 5 plus 7? Negative 2 plus negative 7. Are you doing minus negative 7? It's negative 2 plus negative 7. And so here we get here. Okay? All right, let's look at the one right below it. Sorry, I'm kind of jumping all over the place, but you'll forgive me, right? Let's look at this one. And then I'm going to let you guys try these right here, okay? What sign is in the middle? Minus sign, okay? With subtracting, we kind of got one more step right there, because when I'm subtracting something, you can think of that as needing to distribute like a negative 1 right there, okay? If it helps you to write a negative 1 right there, then go for it. But what has to happen, this is a little bit trickier, is you have to bring that minus sign to everything that goes after it, okay? You got to distribute in that negative sign right there. Nothing in front of it should change. So with subtraction problems, and again, I would label this as an add. This is an add because there's a plus sign. This is a subtract. So you got to be extra careful. These, I always rewrite. I rewrite subtraction problems every single time because I think it's not worth making a tiny mistake. Nick, are you with me? Yep. We're on this problem. Please stop doodling. Okay, so the first one, I would have 9x squared minus 5. Nothing changes with that. Because is there anything in front of 9x squared minus 5? No, I just brought it down. I dropped the parentheses. Daniel, is that okay if I drop the parentheses? Yeah, it's okay. All right. So now the next thing I want to do is distribute that in. Cruz, what's going to happen when I bring a negative into a positive 2x squared? What's that going to become? A negative 2x squared. Okay? Mohammed, what happens if I bring a negative into a positive 5x, what's that 5x going to turn into? A negative 5x. And then Emma, what's going to happen if I bring a negative into a negative 6? What's it going to turn into? Positive. So do y'all see what happened? The first parentheses, nothing changed because there's nothing in front of it. The second parentheses, all the signs flipped. My positive became a negative. My positive became a negative. My negative became a positive. And now it's just like the problem above. Put it together. X squared goes with x squared. All right? 9x squared and negative 2x squared. Combines to be what, Daniel? Do the exponents change?
Exponents stay.
Exponents stay today. Exponents stay today. When you're
We're not
just
multiplying or dividing. If we multiply and divide, that's when we mess with the exponents. Otherwise, you just write the exponent down like you see.
it's just a label. It's telling you that those guys match. Okay? Done with the x squareds. All right, the next thing I would do is the x's. How many terms have just a plain x on it? 1. So just bring it down. Minus 5x. And then I'm going to put the constants. What are my two constants? Negative 5, positive 6.
Wait, how'd you get negative 5x? It's positive.
No, you have to bring, that's what I was talking about at the beginning. You have to bring the negative into all the terms. All the terms after the minus sign have to change. And y'all that don't like to write work, Brayden, and others in here, this is worth writing an extra step because you've got to switch all those signs. Okay? All right, negative 5 and 6, what does that combine to be?
1.
What kind of 1? So plus 1, and I'm done. Finish right there. Okay? Try this one. It's a, circle the sign. What sign is it? What sign is this right here? Subtraction. So think about what you need to do. You might want to be drawing your arrows. The arrows only go to what's after it. Everything in there, what's going to happen to the sign? It's going to flip. Rewrite it, combine. Okay? All right, so with this one, remember, if there's anything in front of the parentheses, we need to distribute it in. But for this first guy, what kind of polynomial is this? How many terms are there? 3. So let's say trinomial. For the first trinomial, is there something we need to distribute in there? No. So does anything change with that first trinomial? No. Do I need parentheses around it? No. So I'm just going to drop those because I'm rewriting it and I'd rather write less anyways. Now, the second guy, what kind of term is that? 1, 2, 3. What is that? Well, what vocabulary word is it? There's 3 terms. Trinomial. Very good. Okay. Now, there's a minus sign in front of it. Anytime you have a minus sign in front of it, you have to bring that in to all the parts. So I drew 3 little rainbows. Okay. So that's telling me I got to change it. A minus sign, just a minus sign, only changes the positive and negative. So if this is a positive 4x squared in the parentheses, what's it going to be when I bring the minus in? Negative 4x squared. A positive x turns into a negative x. What can you put in front of that if you want to know the number? 1. Do you have to do it? No, it's up to you. Positive 10 turns into a negative 10. And this is really important, guys. It's got to go to everything after that minus sign. Please draw the arrows, okay? Then I combine. I'm going to do my x squareds first because that's the highest exponent. Are my exponents changing when I add and subtract? No. Yell it from the rooftop, okay? What is 3x squared minus 4x squared? 3 minus 4. What number is that? Negative 1. Do you have to put the 1? No. Can I put negative x squared? Yes. Can you put negative 1x squared? Sure. If it's multiple choice, they're going to write it like that. Okay? But it's got to be negative. Okay? Check, check. Next thing, I'm going to combine my x's. 2x. Negative 1x. What does that combine to be? Positive? Is it negative? What's 2 minus 1?
2 minus 1.
Positive 1x.
Positive 1x. So plus x. Again, you could put the 1 there. I'm not. And then my last guys, Ethan, what'd you get for the constants? What? Well, what do you think? We got a negative 6 and a negative 10.
Oh, negative 16.
Negative 16. Constants are the plain numbers. So we're done. And we are finished. And we've simplified. Y'all see how it was a lot more expanded at the beginning? And we've shrunk it down. Okay? All right. The last one I want to talk about, what's different about this guy? What's in front of the first parentheses? A negative 7. So what does that mean I have to do? I do have to change the first parentheses. I have to multiply everything by a negative 7. So I'm going to go ahead and draw those arrows right there. Let's go ahead and do that. We'll do this one together. This is kind of weird. We got this from a star from a few years ago. They put multiple letters in there. But again, you just got to think about what matches when it comes to putting it together. Okay, so what's negative 7 times 5, positive 5, xy? Negative 35xy. I know it looks weird, but we're good. Okay, Brayden. Negative 7 times positive 3, yz.
Negative 21 yz.
21yz. Heidi. Negative 7 times negative zx. Heidi. Negative 7 times negative zx.
Negative 7zx.
What's the negative times negative?
Positive.
Positive 7 zx. Ugh, you can. Yeah, we saw this on the star, so that's why we put it on there. All right? Now, that's the only thing the negative 7 goes to because the parentheses are closed off. Okay? Cruz, do I have to distribute something in the second term?
Yes.
What kind of term is this? Second guy. Binomial. Okay? So I'm just distributing just a what? Just a negative. That's like a negative 1. If you want to write the 1 there, then you can. If not, we just know a negative is going to change the sign. So what is that binomial going to turn into?
Negative 2yz.
Negative 2yz and negative 5zx. Sorry, I'm running out of room. I wrote too big. Okay? All right, are we done? Going to call it a day? Put a big circle around it? Is there anything we can combine? We're looking for matching. Let's do xy first. I'm just going to go left to right. I'm going to underline xy. Does this have an xy? This second term? Does this have an xy? Does the next one have an xy? Or the next one? Okay, so nothing to do with that. Negative 35xy. Done. Okay? Now I'm going to circle my yz's. Negative 21yz. Does that have a yz?
No.
Does this have a yz?
Yes.
All right. And how do I combine those? Negative 21 and negative 2. If you borrow $21 and then you borrow 2 more, how many dollars have you borrowed?
Or negative 23.
Negative 23 what? YZ. And again, none of that's changing. The terms are just, the variables are kind of just labels that, hey, these guys go together. Done, done. And then my last one is 7zx and negative 5zx. Those go together. Well, 7 and negative 5.
2.
Positive 2.
Plus
Zx. Woo! Was that terrible?
yes.
It
No.
was not terrible. Not terrible.
Yes, it was.
No, use the restroom.
There's a line for the bathroom, so just give me a second here. Okay, so here's what we're gonna do now. We are going to take an exit ticket at the end. I think it's only 2 or 3 questions, so I'm gonna give y'all a couple minutes to practice. If you go on Canvas, there is a GIM kit, okay? Right here. I want you guys to go on, play that for a minute, and then I'm gonna set an alarm for 10:15, and we will start the exit ticket at 10:15. Okay, so that's what we're doing there. I'm going to be coming around to some of you guys, and we need to schedule a tutorial for exponents if we didn't do so well on that CFU. But that'll probably be a next week problem. Okay, All right.
See that,